Hello, lovely people. What is up? Today we are solving Leetcode problem number 3296. Minimum number of seconds to make mountain height 0. So you can either choose to read all of this or I'll explain it in a bit. So what we have here is we have a let me switch to pen here. We have a mountain that is given to us and a few number of workers given in an array. We need to find how many workers can work simultaneously to reduce the height of mountain. So here in the given example, 2, 1, 1. So according to the given condition, to reduce the mountain's height by some number, let us take 1. What we should do is we should take the worker time given here and perform some operations. For 1, we just take this worker time and apply it. But if we want to reduce the mountain by 2, what we should do is we should take the time taken plus 2 into 2. So the answer will be 6. Now again, if we want to reduce the mountain by 3, what we do is 2 plus 2 into 2 plus 2 into 3, which will be 6, 4, 12, and so on. So to solve this question, if we do it by this and then what we do is this plus 2 into 4, which is 24. And then we have to add all of this plus 12 plus 6 plus 2, which will take a huge amount of time. So what we can, another important thing here given to note is simultaneously all workers are working. So what we could potentially do is take the first worker and make him reduce first one step, so 2, and then take the second worker and make him reduce 2 steps, so 1 plus 1 into 2, which will be 3, and then we take the third worker, make him reduce 1 step. So if you take a look at all of this values that we got, 2, 3 and 1. Also note that in question written an integer representing the minimum number of seconds required for the workers to make the height of mountain 0. So from this values that we have found, we should take the maximum value and return it. So now we are taking maximum because all the workers work simultaneously. So the total time is determined by the slowest worker. So the basic idea to solve this question is instead of trying all distributions, we always choose the worker who can finish the next level the fastest. So this is very similar to scheduling tasks. So we can use min here to find out what we need here. So what do we store in the heap? Each worker stores a tuple. So accumulated cost, base cost, and next count. So for example, the worker with base 1, the value of the tuple will be 1, 1, 2. So 1 is the accumulated cost and base cost is also 1, and the next level multiplier is 2. So first we initialize the heap. For every worker with time t, we push t, 2. Why? Because first level cost is t and next level multiplier is 2. Let us assume we need to remove h levels. So we run the loop for each level in mountain height. And then to pick the fastest worker, we pop from the heap. Heap is accumulated base and count. This worker will finish their current work at time accumulated. That is the first value in the tuple. Since the workers run simultaneously, we update the global result as result is equal to maximum of result, accumulated. This tracks the slowest worker so far. And then we update the workers for next task. So next level cost is base into count. So new accumulated cost will be new cost equal to accumulated plus base into count, which increases level counter, which is count plus 1. And then we push back new cost, base, count plus 1. Then we loop this n times until we find the answer, that is reduce h levels. We repeat it h times. The time complexity for this particular to run this particular algorithm is O of n log n or O of n log w, because then heap operations take O of log w and the loop runs n times. So O of n log n or n log w. Now let's start coding. So first we declare a heap. Heap is equal to, we open square brackets, and then we initialize the heap. For t in worker times, heap q dot heap push heap comma t comma t comma 2. This line is to push the first level cost into the heap. And then outside of the initialization of heap loop, we initialize a variable result equal to 0 to track the final values. And then we start removing the mountain levels one by one. So we start a loop for I in range of mountain height. Accumulated comma base comma count equal to heap q dot heap pop of heap. Here, heap pops the smallest accumulated cost worker. Next, to track the slowest worker so far, we do result equal to max of result comma accumulated. So to compute the next cost, like we saw before, base into count. So new accumulated cost becomes new cost equal to accumulated plus base into count. And then we push worker back. So heap q dot heap push of heap comma new cost comma base comma count plus 1. Why count plus 1? Because next multiplier increases. And then finally we return list result outside of the loop, that is run. So this is the minimum seconds needed to reduce the mountain to 0. So as you can see, the code is running in the most optimal time possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.